Perceptron 2. In this module, we will discuss the general procedure adopted by these perceptron algorithms to solve a specific task. From the previous module, we have a general idea about the introduction and the strategy and inspiration of these algorithms. The perceptron, they're comprised of a data structure, which is basically the weights in the system, the data structure, and they have a separate procedures for training and applying the structures. The structure of they're just vectors, the vectors of weight, and one weight for each input signal they have, and they also have a Bayes term. So the Bayes term is the unique property. Previous algorithms of the neural network we studied so far, they are not using the Bayes term basically, but in this specific case, they are using the Bayes term as well along with the other input signals. Now, first of all, weights will be initialized for all the input signals for the input vectors. The weights will be initialized for each input plus an additional weight will be initialized, and that additional weight will be initialized for this biased term, that biased input signal, and that biased signal for that biased signal usually a constant value will be initialized, which is usually and always equals to 1. The activation of the network to a given input pattern is calculated by the following equation. Now the equation is the activation of the network to a given input is equal to summation of n, where k equals to 1, into w of k multiplied of x of ki plus w biased multiplied by 1. That's because the biased term was initialized with a constant value of 1. In this equation, these all will give rise to the activation of the network. In this equation, n is the number of weights and inputs. X of ki is the kth attribute on the ith input pattern, and w bias is the bias weight. The weights are updated iteratively in the perceptron algorithm according to the error presented to the system, which is due to the comparison in between the actual output and the expected output, and that error is being presented to the system, and then the system modifies accordingly the weights. So the weights are updated according to the following equation. Wi of into t plus 1 is equal to wi into t plus alpha into e into t minus a into t multiplied by xi into t. Now what these abbreviations stands for in this equation of updating the weights. This wi is basically the ith weight at time t and time t plus 1. This is the initial time and the time t plus 1, where this alpha is the learning rate. The learning rate e of t and this a of t is basically the expected and the actual output at time t, and x of I is the ith input. This update process is applied to each weight in turn, as well as the bias weight with its contact input. So the same update process, the same update equation is applied to both the expected input signals and the biased input. The perceptron can be used to approximate arbitrary linear functions, and can also be used for regression or classification problems. So depending upon different types of problems, it has the capability, these algorithms has the capability to be used either to the arbitrary linear functions or to the linear to the regression or classification problems. We have a number of classification problems are there in the real world or in the biological systems where classification, but regression problems are also very important and are there and are important to be solved in different types of scenarios. Now, one thing to be noted is that the perceptron cannot learn a nonlinear mapping between the input and the output attribute. So this is one of the limitation of the perceptron. But if we do not have these type of problems, then perceptrons are very good in work actually. जो प्रॉब्लम हमने डिस्कस किया कि आर्बिट्री नॉन लीनियर मैपिंग they cannot learn. So the XOR problem is one of the classical example of a problem that the perceptron cannot learn. Input and output values. Input and output values should be normalized such that the learning rate controls the amount of change each error has on the system. So the input and output values should be normalized before going into the next of the iterations or the system updation process. Lower learning rates are usually common to be applied and that common such as 0.1. So these lower rates are usually commonly used in these perceptron algorithms. The weights can be updated in an online, it means in real-based manner or in batch. So the weights can be modified either in online, inline manner or in batch. इससे मतलब ये है कि सिस्टम्स में ऐसा भी किया जा सकता है कि जो अपडेशंस है, जो वेट्स की मॉडिफिकेशंस है या वेट की जो अपडेशन है वो बैच में भी की जा सकती है कि बहुत सारे जो मल्टीपल है, मल्टीपल को इकट्ठा प्रोसेस करके अपडेट किया जाए या वन बाय वन किया जाए. दोनों पॉसिबिलिटीज़ जो है वो परसेप्ट्रॉन एल्गोरिथम्स में अवेलेबल है और हम उनकी जब वेट्स अपडेशन करेंगे तो दोनों possibilities are there either in online updation or in batch updation can also be performed in these perceptron algorithms.